Mechanical applications of ordinary differential equation. Mechanics is related with motion of particle. Let a body of mass m starts moving from a fixed point along a straight line under the action of a force F. Suppose in time t body covers a distance small x called as displacement, then velocity is given by v is equals to dx upon dt, and acceleration is a is equals to dv upon dt, and also we can write it as a is equals to v into dv upon dx. And according to the Newton's law of motion, what is a force? It is given by F is equals to mass into acceleration. So these are some basic concepts that we have to remember. And as we are going to see here, mechanical applications of ordinary differential equation, which is of first order, first degree. So here, let's solve the example based on this. This is our first example. A particle of mass m moves under the gravity in a medium whose resistance is k times its velocity. If the particle is projected vertically upward with velocity v, then show that the time to reach the maximum height is m upon k log 1 plus kv upon mg. So we have to show t is equals to this. Okay. So first of all, let's write from given part. Let's consider here mass is m and velocity, it is v. Now we have net force acting on the body. As you all can see, a particle of mass m moves under gravity. It is moving under gravity and it is projected vertically upward. Means if I throw a ball in upward direction, it will come down. At that time, gravitational force acts negatively, and also resistance is given to you, k times its velocity. Means both these forces are acting on that body in negative manner. So net force acting on body, that we can write mass into gravity, which acts negatively, and also resistance, it is k times velocity. So this is the net force acting on the body. But by Newton's law, force is given to us mass into acceleration. So we can compare these two equations. With the help of these, we are having equation mass into acceleration is equals to minus mg minus kv. As I already told you, what is acceleration? Yes, you can see here. Acceleration is rate of change of velocity with respect to time. So replace your value for this. We get mass into dv upon dt is equals to minus mg minus kv. So if you observe, this is our linear differential equation in v, because we are having the term v having degree 1 and its derivative, it also have degree 1. So let's solve here equation as we solve the linear differential equation. First of all, divide by m throughout the equation. So here m will get cancelled, minus k upon m into v. Now we have to shift this term on left side. We have to write into the standard form of differential equation, plus k upon m into v is equals to minus d. So if I compare with the standard linear differential equation, we get here value for p, it is k upon m, and value for q, it is minus d. So as we have the values of p and q, we can find integrating factor. Integrating factor is given by a to the power integration p dt. Now why dt? Because we are having the differential differential equation and we are having the derivative of v with respect to t. So when there is a differentiation with respect to t, we have to take the integration with respect to t. Okay, now putting a value for p, we get e to the power integration p, that is k upon m dt, and on integration we get integrating factor equals to e to the power k upon m is constant with respect to t, keep outside, and integration of constant is t. So this is our integration constant, integrating factor. After finding integrating factor, we need to find solution. What is the solution? Yes, this is the derivative of v with respect to t, so it will give you the solution for v into integrating factor is equals to integration q into integrating factor dt plus c. Now putting your values, v into integrating factor e to the power k upon m into t is equals to integration q. We have to replace q here. Q is what? Minus g. Here it is the value for q into integrating factor e to the power k by m into t dt plus c. On integration, minus g is constant, keep outside. Integration of the exponential term, it is as it is, and divide by the constant term k upon m plus c. So this is our integration. Let's write it into the simple way. E to the power k by m into t is equals to minus g, m will go in numerator, upon k e to the power k by m into t plus c. Now here, dividing by this exponential term, we get v is equals to minus gm upon k. This exponential term will get cancelled, plus, now exponential term is not present here. So when we divide by this exponential term, in numerator, we can write it minus k by m into t. Now this is our required equation, but here integration constant is present. We need particular solution. So we have to remove this integration constant c, and we are going to remove it with the help of initial condition given to us, and that is what? If the particle is projected vertically upward with velocity v. So initially when your particle projected vertically upward, then your velocity is capital V, and at initial time will be 0. So putting all these conditions here, we get capital V is equals to minus gm upon k plus c e to the power, if I replace here t by 0, it becomes e to the power 0, and from this I will get here value for c, that is v plus mg upon k. Now we got integration constant, and next condition that we are going to see, we have to show that the time to reach maximum height. So what if the object goes at maximum height? Yes, definitely at maximum height, your velocity becomes 0. So using these two conditions here, one is put the value of c, and second is put v is equals to 0, because we need to find the time at maximum height, and at maximum height definitely velocity will be 0. So we get the equation. This is our equation. Put your values. Small v is 0, minus mg upon k plus c is replaced by capital V plus mg upon k e to the power minus k by m into t. Now shift this on left side, that will become plus plus mg upon k is equals to, and I'm doing here cross multiplication, kv plus mg upon k into e to the power minus k by m into t. K get cancelled, so we get here mg is equals to kv plus mg e to the power minus k by m into t. Now we are going to shift the term on left side and this mg on right side. So we get e to the power k by m into t is equals to kv plus mg upon mg. And if I separate the denominator, it will be kv upon mg plus 1. Now I want to remove this exponential. So if we take log on both sides, exponential will get removed. K by m into t is equals to log of kv upon mg plus 1. And definitely, if I shift the term k by m on right side, we get t is equals to m upon k log